Okay guys, in the previous video I showed you how to do um, the two-dimensional graph of the projectile by hand when you have constant velocity in the x-axis, so the dots are equally separated, and then you see the dots getting closer and closer on the y-axis because the acceleration is slowing the object down when it's going up. The velocity is 0 at the top for an instant and then speeds up as it goes down. We are going to do this graph using sheets. So you open sheets, and the first column, let's call this projectile. Is going to be the time in seconds. The second column is going to be the x position in meters, and the third column is the y position in meters. We are going to go by a tenth of a second, so you put 0.1, 0.2, 0.3, 0.4, 0.5. Let me pause the video. Up to 2 seconds. So you put the times up to 2 seconds. I like to center the columns. And let's put 1 decimal place for everybody. Now, what's the position? Again, the initial velocity in the x-axis is 5 meters per second, and the initial velocity in the y-axis is 10 meters per second. So here is just, you press the equal sign, it's just going to be the velocity times time. But she doesn't know what time is, so you click the first time, that is at column A, row 2. And yes, 5 times 0 is 0. But you click the point back, and when you drag it from the bottom right corner, you get the time times 5 times 2 seconds is 10 meters. 5 times a tenth of a second is half a meter. So it's just velocity times time, no acceleration in this axis. On the y-axis, we have the initial velocity, which is 10 times t, minus 1/2 g, 1/2 9.8 is 4.9, times t squared. But again, she doesn't know what is t, so instead of putting t, you click the first time, that is A2, and to do the square is this symbol, that is where number 6 is. Enter. Again, 10 times 0 is 0, 4.9 times 0 squared is 0, but when you click from the bottom right corner, it updates to the second row. If you click over here, you see you are on row 3. And if you click over here, you are on row 9. So it's taking these times accordingly. So this is how you calculate the position in the x-axis and in the y-axis. Now let's do the graph. You click a blank cell, go to Insert, Chart, select the scatter plot, and now the range is, as you can see over here, is x. So you put B2 semicolon B up to 22, comma, and the y's are the y's, so it's C2 semicolon C22, and you clearly see the trajectory of the object going up and then down. So like always, I like to put the point small, and this is a parabola. So instead of linear over here on the trend line, you select polynomial second degree is a parabola. Okay, and label, use equation, and that's fine. But let's put y equals. So click it, copy, go back to customize, and trend line, you now put custom and paste it over here. And the reason I'm doing this because I want to put y equals. As you see, the first number is supposed to be 0, and we got 10 to the minus 17. Okay, because at x0, y is supposed to be 0. What these numbers are is very interesting. I will explain that in class. But this is not time. This is y versus x. And let's put that in the axis titles. The vertical is y in meters. And the horizontal is not time, like we have been doing, is x in meters. And this graph is complete. To save it like a PDF, you just click over here, the 3 dots, download PDF, and this, you need to submit this graph from a grade. Again, this is how we did it by hand. Constant velocity in the x-axis, acceleration in the y-axis, and this is how we did it on sheet.